Hello and welcome to this presentation on Sonosthesia, which is a project that aims to create artistic, immersive, interactive audiovisual experiences in virtual reality. So the first thing I'm going to do is give you an overview of existing software in relation to the project, mostly digital audio workstations, visual programming environments, and VR and AR engines. Then we're going to look at how Sonosthesia fits into that picture and the main driving idea behind the project, which is to connect these very different types of software together in order to allow them to interact in real time. And then we'll have a look at the different tools that are offered by Sonosthesia in order to actually make this happen. So first we're going to look at digital audio workstations, which are used extensively by musicians, recording engineers, producers, anyone who has anything to do with music and music performance and music recording uses these tools. They're very good at doing sequencing, orchestrating, writing scores, editing MIDI notes and control values, and handling tempo changes and loops, automation, metadata. You can set up complicated recording sessions. You've got a mixer with channels and buses, and you've got a very powerful plugin architecture which allows you to insert sound processing elements into each channel and each bus, like dynamics, compressors, EQs, reverb, delays, flanges, etc. Now, this plugin architecture that allows zillions of external plugins made by external manufacturers to be usable within these host applications, and you can get just tons of synths and effects, and whatever you're looking for, whether it's calm, dreamy, scary sounds to nasty and mean leads and basses. If it's orchestras or choirs, you name it. If you're looking for it, there's probably something out there that does what you're looking for very well. And also there's just tons of hardware that is used to send mostly MIDI control messages so that musicians can set up for live performances and have lots of keys and sliders and buttons in order to control things in real time. So we've got a really just powerful set of tools here in order to build and perform music, and these are really extensively used throughout the music industry. Then there's another breed of tools used mostly in audio-visual arts, and these are called either visual programming languages like Max and Pure Data, and you also have actual coding libraries and programming environments like processing and open frameworks, which allow the creation of really amazing audio-visual arts using creative coding and computational creativity. Now this is a lot more technical in many ways. It's very present in academia, and there's been quite a lot of artists recently using these tools that have started making an impact on the general public. Now, using these visual programming environments, what users do is that they create patches by arranging and connecting building blocks, objects that have inputs and outputs, and they offer a very much more lower level and technical approach to the visual and sound synthesis mechanisms. And you can design control flows with control data, audio data, and video data, and make really cool cross-domain mappings between all these things in order to create a really symbiotic art where the audio and the visuals don't make sense without each other, and they really function as a whole. So yeah, you can do some pretty awesome stuff with these tools. It's just that it requires a lot of technical knowledge, that and so the bar of entry is pretty high. But once you know how to use them, there's a lot of stuff you can do. And then there's virtual reality, which has been seriously taking off this year. There's all the big tech companies are pouring mountains of cash into the VR and the AR market to try and be the first to get it right. And so you can get things like this nowadays, like the HTC Vive, which offers a couple of tracked controllers with lots of pads and buttons and a VR headset, and everything is tracked using this lighthouse system, and it really offers a very convincing virtual reality experience, which is starting to be affordable, even though it's still quite expensive. VR is really hitting home right now, and there's a forecast to see a big jump in sales for this kind of gear. And in order to develop applications for these VR headsets that are coming out, there's essentially just two options. There's Unity and there's Unreal, which are game engines which have evolved to adapt to the VR platform, and they essentially target all the relevant VR headsets right now. And they offer a whole load of tools which are really useful for VR development. They've got a full-blown programming environment combined with a visual scene editor, which allows for game and level designers to have a more visual approach to designing games. They've got great compatibility with all the modeling software packages like 3D Max, Maya, Blender, Lightwave, etc. They've got amazing physics engines which you can use to create realistic simulations of reality inside your virtual environment. And in the context of the project, this is really useful because we can use the physics engine as an input sensor and as an artistic tool as well. Then they have massive asset stores as well, with all sorts of things relative to game and VR development, like networking libraries or 3D animated monsters or water effect shaders, or just a wide variety of different assets that you can download and use within the editor really easily. And so the driving force behind the project is that you can use virtual and augmented reality as both an audio-visual rendering context for real-time generation, and you can also use it simultaneously as a performance environment that allows you to generate control data by manipulating objects in the scene or manipulating the environment in some way. So this is the starting point of the project, really. We've got 3 types of software that have very different approaches to content generation and very different UIs and demand very different skill sets, and they guide content creation in very different ways. And the goal of the project is to merge all these tools together to allow artists to create an immersive, interactive audio-visual experience. And to do that, we've come up with a protocol for them to exchange data in real time, and developed a set of tools which allow them to actually do that in a concrete way by exchanging input and output control messages through a central hub, which allows to map these messages from one software component to another. So this is an example setup. There are many others, but it's one that I'm quite keen on. So if you imagine you've got a Unity app that has a user that it's interacting with the environment using the controllers that are available, and manipulating objects with the scene, either directly with the controllers or using some kind of controller extensions that I've symbolized here, like you would use a bow for a violin, or some tool that you would use to interact with the real world. In this case, you can replicate that. And so the user manipulates objects in the scene, and the different contacts and with the objects are analyzed, and there's control data which is generated from that, and that control data is sent through to the hub, which is symbolized as the little circle in the middle, and then the control signals are mapped to synthesis control parameters, which are then sent to some musical setup using the digital audio workstations and synths connected to it. And so this generates sound, and then the sound is analyzed within the digital audio workstation, and analysis information is fed back to the hub, which is then mapped in order to control the scene in Unity for controlling, for example, colors or textures or particle systems or turbulences or whatever you can think of. And in this way you've got a bidirectional interaction going between the Unity environment and the digital audio workstation. Another slightly different setup would allow a user to use augmented reality in order to augment his musical performance setup. So if you imagine you've got a musical performer that uses keyboards and buttons and pads in a more traditional kind of setup, you can use this approach to add a layer of augmented reality content on top, which he can combine with his existing setup in order to provide additional input opportunities, and also provide a context for which to do graphical rendering in order to have visuals in real time happening. And another cool thing about Unity is that it has really good multiplayer facilities which allow networking and multiplayer games to be developed relatively easily. And so this would allow an audience to also have access to the augmented content. And so instead of just watching the user move his hands in an empty space, the audience would see the augmented layer and have access also to the procedural graphics that are generated in real time. And so it just augments the performance environment for both the performer and the audience. So these are just two possible setups. There are many others using different types of software, but I just wanted to give you a taste of what's possible with these tools. So just having a quick look at the protocol and architecture of the system, we've got a protocol that's inspired by MIDI, and which is a musical control protocol which handles notes and velocities and channels and volume, panning, and all sorts of things related to music. And the field of multi-agent systems, which has come up with a lot of interesting stuff on how to have multiple heterogeneous systems interacting and communicating with each other. So the idea is that you have components that expose input and output channels, and now these components can be anything you want. There's something like a digital audio workstation, or a VR or AR engine, or a max patch. It can be anything else really. It's just a grouping of different channels that declares itself to a central hub. And then you have input and output channels. The input channels allow the component to be controlled from the outside, and the output channels allow the component to give some description of its internal state to the outside. Now, one of the main differences with MIDI is that channels in Sonosthesia can have varying parameter sets depending on what they're representing, because we don't only want to represent MIDI notes. We want to represent graphical constructs, haptics or physics, or any kind of thing that can relate in some way to interactive audiovisual arts. We want to be able to represent different kinds of things, and so we can have channels declare their own sets of parameters. Now, in the same way that a channel in MIDI allows a MIDI note to be created, and each note has its own, say, velocity and its own pitch, channels in Sonosthesia allow instances to be created and controlled and destroyed. So each instance replicates the parameter set of its associated channel, and then we can control the parameter set of each instance separately using control messages, and then we can destroy it with the equivalent of a note off message in MIDI. Now, a crucial aspect of components is that they are unaware of the global environment. That is, they don't know about other channels and other parameter sets available on other components in the network. They are only aware of their own inputs and their own outputs, and they respond to control data sent to the input, and they perform the analysis required to generate the descriptors that they then send through their outputs. And so they do this by sending and receiving messages to a central hub. And then this hub is responsible for creating mappings between mismatched parameter sets from different channels on different components, and is responsible for relaying messages from one channel to another. So to put this in more concrete visual terms, imagine you have some kind of VR app that exposes an output channel that describes the contact that the user in VR is making with his virtual hands with an object, say a sphere. And so every time the user touches the sphere, there's a new instance created on that channel describing the contact. And when the user stops touching the sphere, that instance is destroyed. And then we have another component on the other side, say a digital audio workstation, which exposes an input channel, which is a synth that can be controlled in the way that a synth would usually be controlled in MIDI, except there it's controlled by equivalent Sonosthesia messages. And so what we want is to link the output channel from the VR component to the input channel on the digital audio workstation component. And to do this, we use the central hub, and each component declares its channel to the central hub, and then the hub can offer a tailored interface which understands the two components, what channels they have, and offer an interface that makes sense to create a mapping between the two channels. And so then what happens is that every time an instance is created or controlled or destroyed on the outgoing VR channel, it's sent to the hub, it's mapped using some channel mapping, and then it's relayed to the digital audio workstation. And conceptually, at least, that's pretty much all there is to it. I've skipped a few complexities, but it's very much the essence of the project. And so now I'm going to give you an overview of the different tools that have been developed in order to actually provide this functionality in concrete terms. So first, there's the Analyzer, which is an audio plugin which can run in any digital audio workstation or compatible host. And what it does is it analyzes the audio data that goes through it. It just lets the audio through unprocessed, but it analyzes it, and then it exposes the analysis data as a static output channels in Sonosthesia terms. It uses the GIST library, so it's got a very wide array of different sound analysis algorithms, time domain and frequency domain algorithms, and it runs on Juice, so it can target VST and audio units and a number of other audio plugin formats. So then there's the Relay, which is also a plugin for digital audio workstations, but instead of analyzing audio, what it does is it exposes automation data that you have on tracks to control any parameter in your other plugins or synths. And it exposes these as Sonosthesia static output channels. And it also relays MIDI data, which it exposes as dynamic output channels on the network. So in this way, you can use the raw input data that you used to make music instead of extracting it later. You can just transmit it directly as controlled data on the network. Then there's the Unity project, which has both a core element, which implements the networking with hub and packages messages for the network, and allows the programmer to expose input and output channels as game objects in the scene, and then allows any other game objects to subscribe to input channels or to send messages through the output channels. And then there's a number of other scripts that implement generators and modifiers for the scene that allow messages to be used to modify the scene in some way. And some interaction descriptors which describe the interactions of the user in some way, and then send that as on output channel as control data. And also a number of links between input and output channels, and some procedural plugins like popcorn effects or substance, and some audio game engines as well. So this is all very alpha and ongoing, but it's a very exciting part of the project. And then there's the hub, which is the central brick in the system, if you will, which allows the different components to talk to each other. And that's implemented using Node and Angular by using Electron to package the two together. So if you're unfamiliar with the JavaScript technologies, there's the Node provides really strong networking tools, and the Chromium aspect allows front-end web frameworks to be used for the UI, and it has the advantages of being both open source completely and very cross-platform. So this is also alpha verging on beta, but it's the core functionality is there. There's some work to be done on the UI, and more sophisticated mappings to be made, but the core functionality is there. So that's it for now. There's a longer version of the presentation, which I thought was a bit too much to swallow for people who are unfamiliar with the project. But if you're interested, you can go and watch that. It goes into a lot more detail in the description of the existing software packages and the thought process behind Sonosthesia, and goes into a lot more technical detail about the protocol and the implementation. And if you want to get involved, then please get in touch. I'm looking to have as many people involved as possible from many different backgrounds, especially artists and technical people, whether it's musicians or sound designers, 3D and effects and animation artists, tech artists and web developers. I'm really looking for this project to become a collaborative effort, so that people can work together to create amazing new content. So hopefully see you soon, and thanks for listening.